Okay, so here's the cliff notes to the balancing redox reactions and some of the things that we need to do here. First of all, if we're going to go through this process, we obviously got to split the reaction into the two halves, the oxidation half and the reduction half. So again, we're assumed we've already got a formula equation, we've already got net ionic. Then we're going to balance the X elements, so the things that are not oxygen and hydrogen. We'll balance oxygen with water, we're going to balance H's with H pluses, and then we're going to balance the electrons and then make sure that they're equal. We're going to add the half reactions together. Okay. Now, we haven't gotten to the bases yet, so don't worry about that. We're going to transfer all the coefficients back to the original reaction and then clean up any loose ends. A couple things to remember here. Don't break apart covalent bonds. This is back to net ionic. If you do the net ionic right, you're going to be okay. Don't break the covalent bonds. Okay. Remember, we break apart ions, but we don't break apart an ion. What did he just say? You break apart ions. I break apart the sodium from nitrate, but I do not break apart a nitrate. That's what we mean by that. Okay, next thing, if we're talking, here's an example, a little more complicated. So let's go through and identify net ionic. We got copper, we got 2H pluses plus a sulfate ion, copper sulfate soluble in water. We got sulfur dioxide, which is covalent, and we got water. Okay. So again, we're going through the steps here. We've got to split the reaction. So before I even do that, I obviously got to do oxidation, reduction, all that stuff. So elements by themselves are pure. Hydrogen's a +1, copper's a +2. Let's see here. Oxygens are -2. So 4 minus 2s is a -8. Sulfur's got to be a 6. Again, we have oxygens, sulfur 2-, so oxygens are -2, that's a -8. It's a +6. Oxygen's a -2, 2 minus 2 is a -4. Oh, there's sulfur changed. And they have +1, -2 for hydrogen and oxygen. So if we look at this, we see two things that's changed. We see copper, solid copper, has changed to copper ions. And we see sulfurs in sulfate have changed to SO2. Now, the thing you got to realize here, we've got sulfate on the left, we still have some on the right, and then we got sulfur somewhere else. So what it must be is some of those sulfates must change. Right? So there's our two half reactions. The first one is the oxidation, the second one is the reduction, because why? Copper went from a 0 to a +2. Some of the sulfurs went from a +6 down to a +4. Now, we're not going to write oxidation numbers in the equations. Okay, we're just writing charges for ions. Next step, balance the elements that aren't oxygen and hydrogen, then balance oxygens with water, hydrogens with H pluses, and electrons. This is where we kind of do a bunch of stuff together. If I look at the first one, copper's balanced. There's no O's, there's no H's. The only thing I have left are electrons. Oxidation. Oxidation is lose electrons, oxidation. So that means that copper atom, if it became a 2+, it must have lost 2 electrons. Reduction. Rig and Gur gain electrons. So for sulfur to go from a 6 down to a +4, it must have gained 2 electrons. Okay. Now, got to back up, got ahead of myself here a little bit. We've got to balance the other elements first. Sulfurs are balanced, oxygens are not. I got 2 oxygens on the right, I need 4. So I write 2 waters. Now I've got 4 H pluses or 4 hydrogens on the right. I need to add enough H pluses to cancel it out. Now I can look at electrons. For sulfur, the sulfur here, that one sulfur atom to go to a 6 to a 4, 2 electrons must have been added. So now what I have are the complete half reactions. So if that's something asked in a question, write the half reactions for each, or for the overall reaction, that's what you're writing. Okay, those are correct answers. Those are important right here. This is what we want, because this is what's going to lead us to how much electricity something has. All right, next thing, we transfer the coefficients back to the original reaction, clean up any loose ends and spectators. So if we take this original reaction, and let's say we just bring it down, say, all right, I got a copper above, so I'm going to still have a copper there. I need 4 H pluses, so I need to put a 2 there. I've got 1 SO4, but wait, I've got 2 SO4s now. I'll just hold on to that for a moment. 1 copper 2 plus ion, 1 SO2, and 2 waters. If we now look at everything, everything is balanced. Here's why we come back to the sulfate. Wait, there's only 1 here, but why do I put a 2? Because remember what the original equation shows. We have sulfate. We don't know how much up here. Some stays, some changes. So here's what it is. 1 sulfate actually changed. The second sulfate didn't change. Okay? So there's our balanced chemical reaction. Okay. All right. Okay, what I want you to do here, this is one, when you go through, I'll at least help you identify the oxidation numbers. A couple things you got to realize, potassium doesn't change, oxygen's not going to change, hydrogen's not going to change in compounds. So what you're looking for is something else. Well, we got nitrogen that's bonded in NO3 and NO3, then it's bonded NO. It's bonded differently, a change. Here we've got iodine in a compound, iodine alone. So there's your 2 changes. Okay, so you can kind of eyeball that. Notice here iodine is a -1 and it's a 0 there. Here you've got nitrogens, you got oxygens are a -2, so that's a -6. Hydrogen's a 1, so that's a -5. Nitrogen's a +5. Over here it's a +2. So our oxidation reaction is iodine in Ki, right? Because remember, this is aqueous, so we'd have K plus I minus. So our iodine ion is changing to an I2, and the reduction is the nitrogen in nitrate. And again, it's a strong acid. I break it apart. It changes to NO. Now, these are incomplete, but that gets you in the right direction in terms of now going through the different steps and balancing everything. So, I want you to finish up. So show me. I got a second one here, and then a third one. All 3 of these. This is the basic one. Actually, just stop there. Just do this one, finish this one, and do this one. And then we will talk about those over the next couple days. And that's it.